Hi everyone, in this demo we present our tool that automatically detects for likely design flaws in entire object-oriented architecture. Entire architecture is a recommended industry practice as it promotes separations of various concerns into layers. One commonly used in entire architecture is the separations of class into three stereotypes, namely boundary, control, and entity. Class stereotypes are not just symbols, they come with design rules governing their behaviors and responsibilities. If natures of class is not apparent to developers or its behaviors do not match its stereotype level, developers are prone to make mistakes, violating the rules, especially as the code evolves over time. There are two common rules variant: robustness rules and well-formed rules. Unfortunately, many software projects during development or maintenance have little documentations. Many design documents, including those specifying stereotype levels of the class in a program, are often missing. Such information is not obvious in the source code either due to poor variable and/or class naming, code changes, etc. Also, keeping design documents and stereotypes up to date manually could be time-consuming and error-prone. We implemented our proposed system as an Eclipse plugin and have tested our tool on a number of student projects and real software systems. Our validation detection framework to infer class stereotypes are shown as follows. It has two phases, namely training and violation detection phases. In the training phase, we built a statistical model using a machine learning technique that can discriminate the class stereotypes based on a set of class with given stereotypes. In the violation detection phase, given a class or a program containing more than one class with no stereotype labels, we predict the corresponding stereotype for each class based on the model. There are 5 different processes in the framework. First is the extraction of basic information, and then feature construction. These processes are used in both training and violation detection phases. During the training phase, we use SVM to construct a statistical model. In the violation detection phase, this model is used to assign likely stereotype labels to classes in the test data. The stereotypes are then checked against robustness or well-formedness rules for violations that signify likely design defects. We implemented our solution as an Eclipse plugin. The plugin consists of an additional button in the Eclipse toolbar. In this button, there are multiple options presented to the users: training and violation detections, using either robustness or well-formedness rules. Now, we would like to train a model. Once a user starts the training phase, a dialog box will appear to ask for the jar files of the project along with the files containing stereotypes label for the various classes in the project. User may add more than one set of jar file and its associated stereotypes label. When we are done, we could click the Train Model button to continue. Once our system is trained, it could be used to detect for likely violations of well-known design rules. When we want to check for violations, click the button again and choose one of the violation detection options. In this demo, we choose Check Robustness. Internally, our system will compute likely stereotypes of the individual classes based on internal trained model. This is transparent to the users. The stereotypes in turn would be used to detect for violations that would then be reported to the users in additional tab at the bottom of the Eclipse IDE. User could then click any of the reported violations and our system would bring the users to the code containing the likely design violations. As a summary, we developed a tool that first learns a statistical model to distinguish the various annotations of a class from a training set. This model in turn is used to give labels to the remaining non-annotated classes. Likely design flaws are later detected by finding violations of well-known design rules. Our system has been implemented as an Eclipse plugin. Preliminary experiment results on several small and medium-scale projects are promising.